Hello guys, welcome to my channel Civilology, the study of civil engineering. Today in this video, let us understand what is short column and long column. Columns, as you all guys know, that is a vertical structural member which is subjected to compression loading. And it is not always what it looks like. One cannot say surely whether the column is long or short just by looking at its appearance. However, there is certain criteria on the basis of which you can differentiate between long column and short column. There are 6 parameters in this video which we are going to discuss, which will decide the type of the column rather than just by visualizing the column. So let us discuss these 6 conditions. Okay. The first condition is the slenderness ratio for short column should be equal to or less than 80. What is slenderness ratio? It is the ratio of effective length and K. What is K? It is radius of gyration. And as you guys all know that the radius of gyration varies and it depends upon the end conditions of the column. As you can see over here, if it is pinned ends, if both ends are pinned, then the value of K, which is radius of gyration, will be equal to 1 and the effective length will be equal to actual length. Now what is effective length? Effective length is the length which experiences buckling. In simple terms, effective length is the length when the compression load is applied and the column buckles. So the length which buckles or the length which experiences buckling is called as effective length of the column. So in this condition, when both supports and both ends are pinned, then effective length will be equal to actual length. As you can see over here in second condition, fixed ends and free ends. When both ends are fixed or both ends are free, then the value of K is equal to 2 and it's mean that the effective length will be equal to 2 times of the actual length. Okay, and similarly when both ends are fixed, the value of K is equal to 0.5 and its effective length is equal to half of actual length. Similarly, if pin end and fix end, it's mean that when one end is pinned and other end is fixed, then effective length is equal to 0.7 times of actual length. I hope you have now understand the end conditions. Okay, so K is equal to I divided by A, where I is moment of inertia and A is the cross-sectional area of the column. I have made a detailed video about moment of inertia, the link of which is given in the description. Must watch that video for more clarification. And the second point is that the slenderness ratio for long column will be greater than 80. As for short column it should be equal to or less than 80 and for long column it should be greater than 80. The second point is radius of gyration is more for short column. As you can see over here, the value of K will be greater for shorter columns and K is directly proportional to moment of inertia. It's mean that short columns will have higher moment of inertia and higher radius of gyration. On the contrary, long column have less radius of gyration. The third point is the length of column will be less than 15 times the least dimension of the column. Let's suppose we have a column whose height is 10 feet and this is the cross section of the column and the area of the column is 12 into 15 inches. So the size of the column is 12 into 15 and here the least dimension is 12 inches, which is the smaller dimension or smaller side of the column. So as per condition, length of column should be less than 15 times the least dimension. As you can see over here, 10 feet will be equal to 120 inches and it should be less than 15 times 12, which is the least dimension, and it comes out to be 120 inches is less than 180 inches. Okay, so it's mean that this column can be categorized as short column. On the contrary, the length of the column is greater than 15 times least dimension of the column, then this column will be called as long column. Condition number 4. The short column will always experience crushing failure, whereas long column will experience buckling failure. Point number 5. Short column is subjected to compressive stresses, whereas the long column is subjected to buckling stresses. Point number 6. For short column, the ratio of effective length to least dimension should be less than 12. Let us assume that we have a column whose height is 10 feet, and always look at the end conditions of the support. For this column, both ends are pinned, so in this condition, the effective length will be equal to its actual length. So let's suppose the length of a column is 10 feet and the cross-sectional area shows that the dimensions are 12 into 15 inches. So the least dimension over here is 12 inches. So by considering this condition, LE, which is effective length divided by least dimension, the effective length in this condition is 120 inches, and when divided it by the least dimension, which is 12 inch, we get the value 10, which is less than 12. So for such condition we can say that the said column or the column under consideration is said to be short column. On the contrary, if the ratio of effective length to least dimension is greater than 12, then this column can be categorized as long column. So I hope you have understand the whole topic. That's all for today. In the end, you are requested, if you are new to my channel, please subscribe it and don't forget to press the bell icon to get video updates. That's all for today.